Hello guys, welcome back to my YouTube channel. Today we will learn one of the investment appraisal method, which is the net present value, NPV. And the question that we are going to handle that is going to help us to learn more about it is as follows. You have been asked to calculate the NPV for a project X, initially costing to 50,000 shillings. It has a 10% cost of capital. It generates the following cash flows. So you have been given the cash flows for each year from the first year up to the fifth year and their cash flows in shillings. So the first step in the solution part, we know that the NPV, or rather the net present value, is equals to the summation of the present values of cash flows, of the PVs of cash flows, the ones that you are going to calculate their present values, you less the initial outlay, initial cost outlay. And in this case, so first of all, we'll start with the summation with the cash flows, to get the cash flows, and you have been given cash flows for every year. So we are going to calculate the present values of the cash flow. So what you are going to do, because you have been given the initial outlay, you already know it as to 50,000, and then the cost of capital is 10%, which is equivalent to 0.1 in terms of decimals. So what we are going to do, we are going to write the year and the cash flows in the vertical way, so that we'll be able to compute the present values. So here you write from year 1, 2, 3, 4 up to year 5. Then later you now come to the cash flows. The first cash flow was 90,000, 80,000, 70,000, 60,000, and finally 50,000. So you are going first of all to get the present values, the PVs, and the PV is usually gotten by the formula 1 plus R power negative n. That is the formula of getting the present values, and the R you already know is 0.1. So n will depend with the number of years. So to start with, the first one is going to be 1.1 power negative 1, which is going to be, so for 1.1 power negative 1, we are going to get it as 0.9, 0.909, 0.909. Then 1.1 power negative 2, you also compute that, 1.1 power negative 2, you get is at 0.826. Then 1.1 power negative 3, you get it as 0.1 power negative 3 is 0.751. 1.1 power negative 4, 1.1 power negative 4, you get it as